Okay, grade nines, this is part two of helping you out with your week one homework. This is from page 302, and this is question 11B, okay? Again, it looks like it's setting itself up for kind of like a cross-multiplying situation, so I'm just going to move this over a bit. Oop, I guess not. Okay, we'll start here. So you have negative 7.8 is equal to negative 4.3 over x. You notice x is in the denominator position here, right? So, whoops, gotta change to my pen here. Sorry about that. Okay. All right, so the x is in the denominator position, which means you can't just get rid of the negative 4.3 and call it a day, because essentially if you had the skill set, and you do, if you could get rid of the negative 4.3, you'd end up solving for 1 over x, okay? And yeah, that's no good. You can't solve for a 1 over x, okay? Whenever we solve in algebra, whatever we're solving, we want to have an x equals blah, 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 or a equals yada, 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 right? But in either case, it's x over 1, right? It's a over 1. We do not solve for inverted x's. We do not want the variables in the denominator position. Okay, so what's our strategy? Well, you're familiar with it. If you were to look at this, I'm not really liking that. That 7.8 is huge. Do you guys like how rough this video is? Oh my gosh, such a newbie, Smith. Such a newbie. Okay, let's try that again. Negative 7.8 is equal to negative 4.3. I don't know if I like Screencastify as much, but anyways. Okay, now look what I'm about to do. Negative 7.8 is the same as negative 7.8 over 1. Golly gee, I wonder if you guys can predict what I'm about to do. Yes, I'm going to cross multiply. Okay, I'm going to cross multiply. So what are we left with? Negative 7.8 times x. I don't know what x is. I'm just trying to rewrite the question so it's a little bit more workable, a little bit easier to deal with. Now, 1 times negative 4.3, okay, is negative 4.3. So now we have something that maybe is just a little bit more familiar or a little bit more workable. Let's just see how this works out. So we have negative 7.8 x is equal to negative 4.3. What are we going to do to both sides? This is not a 1x, this is a negative 7.8x. And as your teachers always harp on, the implied operation is multiplying. What's the opposite of multiplying? If you answered division, you win a gold star, okay? And you're going to divide by the exact same number. That's supposed to be a 7 there. And so whatever you do to one side, you've heard this a million times, you do to the other side. What's the net effect that happens here? This all reduces to a 1, a positive 1, or just a positive 1x. But you notice, when we cross multiply, the x was punted up into the numerator position. In other words, we ditched the potential for a mistake over here by solving for a 1 over x. We don't want that. So by cross multiplying, we got rid of all the denominators. Okay, and we got this lovely little equation here to deal with. All right, so back to where we were. All right, so now you have negative 4.3 divided by a negative 7.8. And no, I'm not going to do that by hand. So now I'll just go to Google and we're going to just type it in. Negative 4.3 divided by negative 7.8. Hit it. And we got, whoa, look at that. Nice little run on decimal. Did I type it right? Yeah, I did. So you got a huge decimal there. I believe it says to the nearest hundredth. So the nearest hundredth in this case would be, if my short-term memory is good, it's 0.55. Now you know that a decimal, pardon me, a negative times a negative is going to be a positive. So this answer is definitely going to be positive. I'm just going to double check that, make sure I have my roundings correct. Yes, this is a 1. So this is, over here, this is correct. Okay. So our answer for 11B Okay? All right, I'm just going to pause for a sec, switch to the next question. Okay. Page 302, number 13. It says a roll of nickels is worth $2. Write and solve an equation to determine the number of nickels in a roll. Okay, so like a lot of word problems, teachers, myself, other math teachers you might have had, they're fond of teaching you to start with a let statement. So what don't we know? Well, it says determine the number of nickels in a roll. So we don't know the number of nickels in a roll. Now, if you've ever wrapped coins like I have, I know exactly how many nickels are in this roll, but it does want an equation, so we might as well figure it out. So let x equal the amount. Oh, Mr. Smith is trying to do cursive. Nickels. Oh, not bad. It's almost like I'm in grade 3 again. Let x equal the amount of nickels. Okay, well, what's the value of a nickel? Right? Well, you know what it is. It's 5 cents. Now, there's two ways of doing this. You could write it in terms of cents, or you could write it in terms of dollars. And here's what I mean. So you could say the nickel's literally worth 5 cents. And remember your cents coin? Or you could say in terms of dollars, it's 0.05. Okay? Doesn't matter which way you do it. It's just you gotta talk apples to apples here. If you're gonna solve the problem in dollars, solve it in dollars. If you want to solve the problem in nickels, or cents, then you're gonna solve it in cents. So I'll just show you. It's really the same thing, guys. I'm just trying to show you, because some people don't want to deal with decimals. Okay, let's do the cents one first. Okay, so we don't know the amount of nickels, but I do know that each nickel is worth 5 cents. So if x were equal to 1, I'd have 5 cents. If x were equal to 2, I'd have 10 cents. If I had 10 nickels, it'd be 50 cents. So what I'm talking about is that we have a multiplication relationship. That's where this word, remember I was talking about this word per? Each nickel is worth 5 cents, 5 cents per nickel. Now, in this case, what's it supposed to equal? In terms of cents, right? In terms of cents, it's supposed to be 200 cents. All right? $2 is equal to 200 cents. Okay, again, I mention this because some people, they get a little whacked out when they want to do decimals. So now this is just a one-step equation, and you divide both sides by 5. Okay, that reduces to a 1x. 200 divided by 5 is 40. Okay, what does this look like if you just skipped all that, that cents nonsense and just kept it in dollars the way it's written? All right, well, that's what this looks like. Okay, same let statement, right? Let x equal the amount of nickels. Okay, there's no sense in rewriting it. Same sort of relationship. It's just we're actually gonna acknowledge that in terms of its relationship to $1, a nickel is only 0.05. All right. What do we have here? $2. All right, and then of course it's 5 cents per nickel. All right, so what are we doing to both sides? We're going to divide both sides by 0.05. We're going to divide here by 0.05. So x is equal to 2 divided by 0.05. And x is equal to, shocker, it's 40. Okay? I just wanted to show you two different ways, right? I just wanted to show you two different ways of doing this, all right? If you want to do cents, you can convert your dollars. Remember, $2 is 200 cents. $10 is 1,000 cents. Or if you're fine with the decimals, and I suggest that you should be fine with the decimals, you could leave it in decimal form, okay? Doesn't matter. All right, I'll pause the video and we'll do the last question. Okay, guys, last freebie that Mr. Smith is giving you from your homework. It says, 1 year, a student council sold 856 copies of a school yearbook. 4/5 of the students bought a copy, 4/5 right there. Notice how I'm underlining key phrases here. How many students did not? That seems to be a big word or hint or clue. Okay, so once again, one year, a student council sold 856 copies of a school yearbook. 4/5 of the students bought a copy. How many students did not buy a copy? Well, you just got to use a little bit of reasoning here. If 4/5 bought, doesn't it follow that therefore 1/5, that's the missing fifth from here. If 4/5 bought, doesn't it really make sense to say therefore 1/5 of the students? Apologies about my phone there. 1/5 of the students, I'm just going to mute that. 1/5 of the students did not buy. Okay? Did not buy. So the temptation here in this problem, the little curveball, is that somehow students are tempted to incorporate this little fraction here of 4/5 into the answer. It's not part of the answer because of the way the question is worded. So once again, the most difficult part of a word problem is usually the beginning. You have to understand what the word problem is asking you. Okay, it's not asking you how many students out of 856 bought the yearbook. It's asking you how many of them did not buy the yearbook. So that's why we're going to use the 1/5. That's where the 1/5 came from. If 4/5 bought a yearbook, that must mean 1/5 did not. Okay, did not. That's your key phrase. Now, once you've understood this, and again, there's no mathematical trick. This is all reading comprehension and reasoning. It's logical thinking. Okay. Once you've figured out that only 1/5 of the students did not buy the yearbook, then I would say the problem is relatively straightforward to set up. Okay. So you could just write out a sentence. Ooh, that's not very good. Mr. Smith is still getting used to writing with a pen. Okay. Write out a sentence. Here's what I mean. 1/5 of 856 equals the students who did not buy. Okay. Yeah, that's not a very good buy. All right. See how picky I am? Okay. So you remember how to do these statements from grade 8? If not, I'll show you. Okay. When you have an of statement, 2/3 of 90, 1/8 of 256, 1/10 of 420. When you have a fraction and the word of and then the ending number, it's a real simple conversion to write something out mathematically. First of all, don't change the fraction at the beginning. Of, as maybe you've heard me repeat several thousand times, of means times, and then you don't have to do much here. Now, there's a couple of options here. If you want to go ahead and convert this, and I'm going to do it over on the side then. No, I'll do this in, let's see. I'll do this in this fluorescent green. So over here, if you prefer to say 1/5, Mr. Smith, isn't that the same as, well, 1/5, isn't that 0.2? And the answer is yes. If you'd rather just go 0.2 times 856, yes, you will get the right answer for sure. Or, keeping on with what we were just writing, 1/5 of 856, that's the same as over 1. When you multiply, you just go straight across. So basically, this comes out as 856 divided by 5. Okay? Divided by 5. You will get the same answer. Let's check it. Okay? So let's go over here to our handy dandy calculator. 856 divided by 5. 171.2. There's no way they could sell 0.2 of a yearbook. We got to use a little bit of common sense here. And so it has to be rounded down to 171, okay? Now, the other way of doing it was to say 0.2 times 856, and shocker, it's the same thing. So whether you did it this way and got 171, or whether you did it this way and got 171, it was, let's just have this 171 students. Whoa. Okay, 171 students did not buy. Okay. All right, that's it for today. You'll have week 2 problems coming up in the middle of April, but for now, take it easy, do your homework, keep up, be well. Talk to you later. Bye.